Hey there, class. So we're supposed to summarize this poster board here within 5 minutes, and I guess usually, you know, I like to kind of reread through the instructions, but basically what we're trying to do here is ultimately talk about ATP and CO2 production and how we get to that point. So I'm going to do my best to kind of run through these kind of mechanisms here that we've been working on the last 4 weeks. So, let's say you eat a hamburger or whatever, or if there's lactose right there, I'm focusing on. You can drink some milk. And so you do that, and then all of a sudden your body says, we need some more energy to go about our day. So we start here, we kind of work our way down. We get to glycolysis here, and in glycolysis, we start with glucose, and through a series of reactions, we end up with pyruvate. We also have production of acetyl-CoA as well. And so the glycolysis itself produces very minimal ATP. We need more enzymes and reactions to take place to really have a big payoff. So we then take acetyl-CoA and we can actually insert that into the citric acid cycle here. And through the citric acid cycle, we actually, again, are not making much ATP, but we are creating some electron carriers that will help us create ATP. And during this process, this is actually where we produce a decent amount of CO2. You can see that actually kind of on the right hand there, that CO2 is produced through one of the reactions. So we take our NADHs, our FADH2 that we made it in the citric acid cycle, and then we move to the electron transport chain. And this is where we make the majority of our ATP. So in the electron transport chain, we have the shuttling of hydrogen ions and a series of reductions. You can kind of see that there. We're going from NADH to NAD+. And so it is through this kind of series of reactions and kind of channeling of hydrogen ions, which we can kind of see a little bit better there, that we start creating a electron a gradient, and it is ultimately through complex 4, which is all the way down here, that the hydrogen ions, as they fall down in energy levels, that we create, they go through something called ATP synthase, and that's how we create approximately 32 units of ATP. If you look at other resource materials, sometimes they say 36, and that all depends on if they round up their values of NADH and FADH2 or not. So let's say you haven't eaten. Then what? Well, what we can do is we can start to break down fats, and through fats we can make products that can enter into the previous cycle we had talked about, where we're creating kind of substrates to enter into the citric acid cycle, and then the electron transport chain. We can also talk about glycogenolysis. So this is where we break down glycogen, which almost mirrors the reverse of glycolysis. In many respects, they are somewhat related, but there is much more complex just to say it's the complete reverse. However, we do create products here that ultimately do allow us to, again, go back to the same kind of cycle we started off with in creating the fuel to enter into glycolysis, the citric acid cycle, and then ultimately the electron transport chain.